I'm also proud when people hear difference, because even though I'm not the technical engineer behind the product, I'm the guy who does finance behind the company and marketing and such, but I am very much involved. And whenever we listen, I'm the person who listens to the amp, because we compare measurements with listening. When you design amplifiers, and we sort of knew we had the core in this new sound engine technology, which is basically what you heard between the two.
And it seems like high frequencies a little bit better.
Yeah.
Seems like.
Yeah.
I don't know how to call it.
Less harsher.
Yeah.
Yeah.
Less harsher. Much less harsher.
It adds less of itself. It adds less of these ugly things, and then the music just comes forward. And it sometimes sounds like it's louder without being unpleasant, but it's not louder. In volume 60 to 65, they are equal. So yeah, but when we listen, we measure as far as we can, and then we take it to the listening board, and we try to see if we can detect something wrong. And if we can detect something wrong, we take it back to the measurement bench. And this is the first amplifier we have made that is so-called IP controllable. So you can send it commands over network, and it's a completely open system, so you can talk to anything. You can make your own applications for it if you're nerd enough. You can use all kinds of applications. You can use all kinds of smart homes, if anybody of you have that. But it's also very connectable for digital music, which we think is the future, both for entry level and for high end. Before we play the more music, we'll do the final thing. And for those who have been to a Hegel demo before, you've seen it all before. The big problem with digital is digital sound looks like this. A DA converter or a receiver of digital music, a DA converter, is basically a calculator. And to make it easier, so I don't have to write up so many ones and zeros, let's say that this slot is 16 ones and zeros. This is 16 ones and zeros. This is 16 ones and zeros. This is 16. And they come in this way. So it sends 1, 1, 0, 1, 1, 0. From your phone, your CD player's digital output, your Blue Sound, your Sonos, anything. Or it may come over the network. These strings of ones and zeros goes into the DAC, and it sums them together. It's something called a binary system. So these 16 ones and zeros ends up being a number, for example 1764. It's not what it is, but and this number defines how loud the music should be right now. So you can say that the first bit is this much, the second is this much, the third is this much, and the fourth is this much again. So by taking samples of 16 bits, a single 1 or 0 is called a bit. A sample of 16 ones and zeros on CD quality music is called a sample. Each sample defines how loud the music is right now, and it builds the music signal out of these samples. In CD we call it 16-bit 44.1 kilohertz, meaning there's one sample of 16 bits 44,100 times per second. That is the precision rate of how precise you can build the music signal. If it's high resolution, it's maybe 24 bits, and that can be a bigger number. If it's a higher sample rate, 96K or 192K. The issue here is that the big issue is that the ones and zeros must be received by whatever DA converter there is at a very specific rate. Because the DA converter is designed or instructed to receive the ones and zeros in a very precise manner. It's defined by a clock, it has. So it says tick, 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 1.5 million times a second when playing CD. And then the sender of the signal, if it's a phone, if it's a PC, CD player, whatever, also has a clock that tells it to what rhythm to send these ones and zeros. And they're supposed to have the same rhythm. But they don't, for various reasons, depending on the source and depending on the clock and whatever. And when they don't, this calculator starts to make miscalculations, so it goes wrong. It starts to create sounds that wasn't supposed to be there. And it starts to change, perhaps, the sound level of some sounds, and it adds extra sounds. And it does a little bit the same as the amplifiers, except that it's so bad that it's just a wall of sound hitting you. And that is why you can't hear a specific thing or a tiny detail in the music. And most of the old DA converters just sounded flat and uninspiring, but they could have very good bass because they had better power supply and better this and that. But it didn't have the edge and detail and precision that they should have. And nowadays, almost everyone is using some form of a digital source. And the simpler the devices you play from, the worse the problems is. Because they're clocks that define the rhythm, they should send these ones and zeros out, is not so good. So they make errors that way. It could be that you're shipping it, you're streaming it from a server in Washington or a local server in Istanbul, it goes through the network, timing errors will come up. There's a lot of problems associated with getting digital music to your amplifiers. But because this change that happened in 2005, 6, 7, 8, 9, 10, where the streaming and availability of music was so important, we started working very early on.